A and level B, and or let's say we have 10 factors, right? And we wanted to look at the main effects, so what happens for each factor, as well as all the interactions, right? How many interactions could there be between the 10 factors? Huh? 2 to the 10, there's a lot, right? So that becomes a problem, right? You have to be able to put samples into and design something for all of these factors. So the question then arises, how can we try to understand what the main effects are and some subset of the interaction effects without having to have so many different runs, right? Without having to have so many different partitions. And that's the main idea, okay? And the main idea basically comes from looking at it, is we're going to select the main effects. We're going to make sure that we can test the main effects and the low order effects, but we might not be able to test all of the higher order effects. So that's a basic idea, okay? So there are going to be some combinations that are just straight left out, okay? So here's an example. If I have a three-way ANOVA, factors A, B, C, this is factor A, factor B, factor C, AB. What do you think this is? A, C, B, C, and ABC, okay? Same deal, okay? So if we had even more, there'd be more, and it might be hard to do. Okay, so the idea comes from the following. If I have 2 to the k, right, possibilities, I can think of that as a sum over I equals 0 to k, k choose I. So this is just an equality, and we're going to basically be using this idea, okay? Which means we're going to partition up. What do you think k is? The number of factors, okay? And I is, in a way, the number of subsets of factors we're ever going to look for, okay? And so, if you remember, you saw things like this, right, on your homework, right? The way you read this is that we're going to say that there are 3 factors. That's why you have 3. 2 means for each factor, you have high and low, okay? You have 2 different levels. And so for factor A, B, and C, minuses mean low level, okay? Pluses would mean high level, right? So this would be, what would this would be? Low level, low level, low level for all of them. So that's why, for example, we can think of this as y1, 1, 1. Okay? 1 being low level. If this were y2, 2, 2, what would I have here? I'd have all pluses. Okay? You guys good by that? Okay? General rule, each column sum has to be 0. Why that's true, I'll get to it a little bit later. But general rule, each column sum has to be 0. Okay? So this just means low, low, low. When I write AB, right, this is straight by convention. AB is a plus because negative times a negative is positive, okay? If you think of the minuses as -1, as if you think of the pluses as +1, just think of them as straight multiplication. Okay? Again, I'm going to first explain it mechanically, then we'll go back and get some of the intuition. Why is AC plus? Because A times C is, exactly, 2 negatives make a positive, BC is a plus, and ABC is negative. Okay? We can do the same thing here, we can do the same thing here, we can do the same thing here, we can do the same thing here. Okay? Now, if I read off of these, okay, from these I can tell you what the main effect of A is. From these I should be able to tell you what the main effect of B is. From these I should be able to tell you the main effect of C. What do you think these will tell me? The main effect of? Not the main effect, the effect of AB, right? These will give me the effect of BC, and similarly these will give me the effect of ABC. I'll tell you the rule for that in a second, okay? The rule is actually pretty simple. You add all of the pluses, you add this, 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 and this, you divide by 4, and you subtract this, 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 this. Or you can add them all and divide by the appropriate number. We'll get to that in a second. I'll explain why that's true. Okay? So that's what's going on here, okay? Now in your homework, right, if you notice there's this question of confound is one of the things they ask you. They ask you the level of the design. That's one of the other things they ask you, right? And they ask you the generator. Okay? We're going to go through what the confound is, what the level of the design is, and what the generator is. Okay? Okay. So, what's meant by a confound? Does anyone want to take a guess what's meant by a confound? Anyone want to take a guess what's meant by a confound? Okay, why are we trying to do something like this, right? Before I told you, if we try to write out all possibilities, it would be 2 to the k, right? And we're only looking at a subset of them, okay? And what would we mean by a confound? What did we say we're willing to give up on? It's a higher order interaction, right? We want to get the main effect. We hopefully get some of the lower order interactions. If we lose some of the higher order interactions, so be it, that's life, okay? So that's what we're looking for. So what we mean by a confound is, the way you read off a confound here, is if you have any 2 columns that are identical, that's a confound. Okay? So can you find the pattern of any 2 columns here that are identical? No, right? Why is it the case here that we have no 2 columns that they're a confound? There's a really good reason why there are no 2 columns here that it's a confound. You've got 8 runs. Look, it's 2 to the 3. We can fill out the whole table, right? We can look at all possible cases, right? ABC minus minus minus, plus minus minus, minus plus minus, plus plus minus, blah blah blah, right? We can look at all combinations of ABCs. Okay? Now the problem could be is that if I had more factors, I couldn't look at all possible combinations. Okay, the way that you actually get factors, so if I wanted to get the main effect of A, what I do is I just add them up according to the sign. So it was minus 1 for the first one, plus 1, minus 1, plus 1, and then there are 8 of them, so I divide by 8. So if you look at that, right, I just subtract the first one, add the second one, subtract the third one, blah, 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 right? And divide by 8. How would I get main effect B? What would I add? I'd add these 2, so 3, 4, plus 7, 8, minus what? 1, 2, okay? Same with the interaction effects, okay? The way you get them is by just adding them up, okay? So typically, these patterns are given to you. People work out these designs, they give you the designs, yeah?
When you add each plus, does each plus count as 1?
Yes.
Okay.
If you see plus, it means plus 1. If you see minus, it means minus 1. In this world, there's only plus 1 and minus 1. There is nothing else. Okay? So you are given this as a design. Someone generates this, gives it to you, right? And your job is to compute the main effects and the random effects exactly as the way you said, right? And one of the things you have to worry about is, are there confounds? And if there are confounds, that gives us what the notion is of a level, and it also gives us a notion of a generator. Here there are no confounds, so I can't explain it to you. So let's look at a case where we have confounds. Don't worry about that table for a second. Okay, so now what do we have? We have ABC, right? But how many runs do I have? 4 runs, right? So can I fill out the whole table? No, right? Because how many runs would I need to fill out the whole table? 8, okay? So what do I have? I got AB, so minus minus plus, plus minus minus, minus plus minus, plus plus plus. Can you give me an example? Just ignore all of these. Give me an example that I ignored.
Minus minus minus.
Minus minus minus, right? For example, okay? How did I get a plus? How did I get a plus here? Negative negative is a positive, right? AC is negative, positive is a negative, blah blah blah. Okay? Now, do you see any 2 columns that are the same here? A is the same as what? A is the same as BC, right? A is the same as BC. So there's a confound between A and what? BC, okay? So that's what we mean by a confound. You can't tell these apart. Okay, now there's a confound between what else? C? No. Yeah, C and what? And C and AB. There's a confound between C and AB, okay? So you guys are all good by that, okay? I think we just said this. Columns that have identical entries correspond to effects that are confounded or alien, okay? So this right here is called a level 3 design, okay? Because level 1 and level 2 are confounded. You add 1 and 2 together, you get? Anyone take a guess? 3, right? So the higher the level, the better off you are, right? So if, for example, 2 and 3 were confounded, it would be a level 5, right? If 1 and 3 were confounded, it would be level 4. Yes?
Where are you getting 1 and 2 from?
Good question. So, what is A? Where's my, we have 2 confounds. Let's just look at one of them, okay? A is confounded with BC, right? A is what kind of effect? It's a main effect, right? There's only one thing here, right? Level 1. Only one variable, only one factor. BC is what? How many factors in BC? 2, right? 1 plus 2, 3. So I'm just counting the number of factors in my confounds, and I add them together, right? So let's say this were more complicated. Let's say I had A, right, and it was confounded with ABC. Let's say that were my only confound, okay? Then it would be a level 4, because this is a level 1, right, and this is a level 3. You had a question?
I was gonna say B and AC also, right?
B and AC are also confounded, so that's a level 1, and this is a level 2, okay? So you look at your confounds, and you're going to take the smallest number in the addition, okay? Yeah.
So that was my next question. If you have multiple confounds, so you take your lowest level?
You take the lowest level, yeah, okay? Yes? If there aren't any confounds, you're good, right? It's a full table, right? So if we looked at the previous case, there are no confounds, right? So it's a full factorial design.
So there aren't any levels.
I'm sorry?
There aren't any levels.
Well, you're getting the full thing, right? So what okay, so if I want to think about this, right? Usually don't define, whenever I talk about a level, it's related to a confound, so if there's no confound, it's not quite clear what a level means. But if you wanted to say, I mean, yeah, because it doesn't really have meaning, okay? If you have a full table, you just have a full factorial table, you don't have to worry about the confound, because you're really looking at all possible combinations, okay? Okay. So, that's the idea of a confound. Okay, so this is just wood. Okay. There are 2k minus p ways to, so you guys remember what, okay. K is clear, right? So, do you guys know what we mean by p? So we have 2 levels, right? Each factor has 2 levels. That where we got the 2. K comes from where? The number of factors, okay? And we're taking 1 over 2 to the p fraction of each of the possible factor level combinations. So this is just telling me how many of them we're losing. So if p were 0, what would it be? The design would be full factorial, right? If p were 0, you'd be getting everything, right? So p is telling you what? It's just telling you, what? How many you're losing, how many of the combinations you're losing. That's what p is telling you, okay? Okay. So now we need to find something called the generator, okay? So if you remember, A was confounded with BC. Everyone remember this? And similarly, there was another confound. What was the other confound? B was confounded with BC, right? Okay, so let's go back and look at this. A we said is wrong way, sorry. Okay, A was confounded with which one? BC, right? So what happens if I multiply column A by column BC? What do I get?
ABC.
You get ABC. You also you also get +1 +1 +1, right? Which is also known as ABC. For example, for a second, forget that ABC was all +1. Anytime you see a column that's all +1, we call that the identity. Okay? Anything that's all +1 is the identity. Let me write this down. Okay? And it's also called the generator. Another way of saying it, A times BC is equal to the identity, right? If I were to take column A and multiply it by column BC, it would be the identity, okay? And that's called your generator. Now the thing that's useful or semi-relevant about the generator is if you pick apart the generator, right? Our generator is also equal to A, BC, right? I multiplied A times BC, right? And I got the identity, okay? So if I multiply B times AC, what do I get? The identity, right? So that's also ABC, right? So if you multiply AB times C, you're going to get the identity. If you multiply AC times B, you're going to get the identity, right? And so this again is our notion of the generator. If you multiply A times ABC, you're going to get the Should we do it? If I multiply A, okay. If I multiply, yeah, so again, A times BC is the identity, right? B times AC is the identity. So this lets us take things apart, okay? So what's A times ABC? It's equal to A, right? It behaves like the identity, right? -1 times +1 is -1, right? Anytime, whenever we multiply something by +1, it stays the same, okay? So that gives us the notion of the identity, that gives us the notion of the generator, and that gives us the notion of the levels. Okay, do you want me to go through all of those again in this? We'll do other examples. Okay? Now, do you know why I'm telling you any of this? No. Okay, good. I didn't think you would. I was first just going through everything mechanically so you could do your homework, right? So I think with what I just told you, you can probably do your homework. You don't know why you're doing your homework, but you could do your homework, okay? So, yeah.
Why is it called the generator?
Oh, why is it called the generator? Okay, so the reason it's called the generator is somehow it tells you the fundamental properties about the compounds, okay? There's a deeper reason it's called a generator. Usually, if I were to teach this much more formally, I wouldn't teach it to you this mechanically. You learn it in terms of group theory. There's a generator of the group, and there's an actual algebra that's generating all of these combinations, and that's why it's called a generator. But if you don't want to remember that or don't care, I never said that. Yeah?
You said that P was the number of combinations that you lost. Why is P1?
Why is P1 in this case? Well, because I have 4, right, instead of 8. Right? So, what am I losing?
1/2.
I'm losing about half of them. Okay? So it's 2 to the minus 1. Okay? You don't know which ones. It's not telling you which ones. It's just telling you, hey, you lost half of them. Such as life. It didn't actually tell you you lost half of them. It told you we designed it with half of them gone. Okay? Okay, so now let's go back. Do you want me to do another one mechanically, and then explain what's going on? Or do you want me to explain what's going on first, or
Explain.
explain? Okay. Okay. So let's look at the full factorial design, okay? There's nothing missing here, right? Everyone's good by this, okay? So what you want is you want to write down these patterns of 1s and minus 1s such that if I just add these things up across columns, right, I can get things like the sum squared error. That's basically what I want. I want to be able to get back what I was doing with my two-way ANOVAs, blah, 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 right? By just being able to add up columns, okay? So I want to be able to say, hey, look,